Good afternoon. My name is Abby Lehman with L3Harris Geospatial, and I'd like to welcome you to this live episode of Geospatial Distancing. We've got a good one this week. 3 great panelists and a really cool discussion topic. If you're new around here, you'll notice that we don't run our show like a typical webinar. I would say that we're like a webinar's cool aunt. We're laid back, we're informal, and when your parents aren't watching, we let you get away with anything. So before we get down and nerdy, I will introduce our guest for this week. I'll start with Stuart Blundell, who is the Geo and Business Development Manager at Presagis. He is a bona fide crowd favorite with my team, that is for sure. And if you're familiar with the NB Analytics Symposium, the EAS origin story basically starts with Stuart. He willed it into existence with the same infectious energy that he brings to all his interactions. He has a magic to him that when you're talking to him, you kind of feel like anything is possible.
I'm blushing right now. I just want you to know that.
What was that?
I'm blushing.
Oh, okay. Well, say hello to our audience.
Hello, everyone. It's a real pleasure to be here. I've been looking forward to this all week, and it's such a great opportunity for me to be back with all of my favorite friends at Harris. So thank you, Abby, for the opportunity.
Absolutely. So next, we are joined by 2 of my L3Harris colleagues. We're doing it a little bit different. We've got 2 L3Harris people today. And these people I am referring to as our resident gamers. Our resident gamer number 1 is Megan Gallagher, who was part of our very first geospatial distancing episode. If you were there, you might remember her. She's a solutions engineer, and she's particularly smitten with SAR data. Say hello, Megan.
Hello, everybody.
All right.
Less of an intro, just say hi.
And then on to our resident gamer number 2. This is software engineer Daniel Platt. He specializes as a full stack web developer for geospatial enterprise applications. And when I approached him with the topic of today's show, it took about 2 seconds for him to agree to participate. So, hello, Daniel.
Hey, can you guys hear me all right?
Yeah.
Yeah. All right.
And last but not least, she is the smart, blonde, popular girl you always wanted to be friends with, my marketing colleague, Matria. Say hello, Matria.
Hello, everyone.
So Matria is here to keep our screen shares running smoothly and to monitor your questions that are submitted throughout the show. And a reminder that you can submit your questions at any time using the Q&A button that's right along the bottom of your toolbar. And Matria will keep an eye out for those, and she will assist with directing them to our panel to answer live. So without further ado, let's do this thing. Okay, I'm gonna start with Stuart. I wanna start the discussion with him because he is the one that actually came to us with this topic, this idea of discussing game engine technology and how it can be intertwined with remote sensing data. And I believe it ties back to his experiences working with Viz Sim data. Stuart, would you like to take the reins and give us a little more background on why you brought us the topic?
Absolutely. So let me start with a little story. I want to go back to 2003 at the first GeoInt Symposium in New Orleans, Louisiana. And there was a panel that my business colleague, David Opitz from Visual Learning Systems was on. And there was another guy there by the name of Gilman Louie. And so Gilman is a very influential venture capitalist, and he at the time was the first CEO of what's called In-Q-Tel. So In-Q-Tel is the venture capital firm for the CIA. And what was interesting, after the panel, David and I were talking with Gilman, and he said, you guys really need to take a look at this keyhole thing. And it was like, okay, what's that? And he explained it a little bit. And what keyhole became was Google Earth. And so back in 2003, a little company in California, Keyhole, was acquired by Google. And Google had noticed that 25% of their searches in 2004 had geographic content, directions, locations of objects, these types of things. So for those of you who can remember them, when Google Earth first came into the geospatial marketplace, it completely transformed everything. All of a sudden, people were saying, I didn't know I could do this really simple interface for getting to view any place in the world. And the whole basis of Keyhole was game engine technology and visualization. And I would propose that, really why I wanted to talk about game engines today is we are at that same transformative type of moment in our industry right now, where game engines will be changing the way we look into the future 15 years from now from a geospatial perspective. And I want to just separate, kind of the comments a little bit from my perspective. We're here, I propose game engine technology, not gaming. Gaming is separate. It's an element from what game engine technology is built from. But I really see game engine technology as an innovation platform right now for a global development community. And so let me just stop with that and bring in Megan and bring in Daniel on their thoughts about gaming or game engines and innovation.
Yeah. I mean, I had mentioned when we were talking before, Unreal Engine 5, I got really excited about that. Speaking of, just came out. And no, I mean, it's amazing how every single year there's, it's an exponential growth in technology. And the fact of, if nobody's seen that video of Unreal Engine 5, I encourage you to go watch it. I don't think that's on our clips, is it, Matria?
No, but I would definitely make sure to go watch it.
It's really cool.
As part of my little research session after our initial meeting for this, I went and I just kind of dug into what was out there for the game engine technology, and I watched that demo. It's incredible.
Yeah,
absolutely incredible.
And I think one of the important things as far as new features in that engine for geospatial and using engines for geospatial is usually a 3D artist would have to create this very complex object with lots of polygons, and depending on the performance and how crazy the game was, they'd have to create a lower resolution or a lower polygon count and import that actually into the game. And now they're able to import the full polygon count, and it all it does is just stream it to the highest resolution of whatever that client is using. So that's really powerful when you've got an entire portion of the planet with potentially LiDAR buildings and high polygon count. I'm really excited to see how that is used in the GIS industry.
Definitely. Oh, I was actually just gonna follow up on the LiDAR point, and I mean, we're definitely seeing some growth in these kind of things, like seeing people realizing that, one, we have all these game engines and really cool technologies that are up and coming and just becoming more and more effusive in geospatial itself. And one example of this was actually the lab that I used to work in Boise State, and we were a LiDAR lab, and so fantastic tie-in. And what we used was we actually had a 3D visualization VR system. So we would do collects, or we would have the one was like a CAT scan of a body, and you would put on the glasses and you'd set up the system, and you could go into this cube that was either created by INL or distributed by the Idaho National Labs that would allow you to go in and classify and move the LiDAR points all around while you're inside of them. Because as we see with these larger LiDAR data sets, it's becoming a bit more complicated to view a 3D format in a 2D space, when it's a lot easier to actually have it in that 3D format and do the same kind of techniques. And so with all these new technologies that are coming out and just advances in what we have right now, things like that, where we used to before be sort of stuck behind specific formats and screens, are becoming much more playable, I guess, since this is the gaming one. You can actually play around with them a lot easier and in formats that are much more intuitive for people to start off and just sort of get running with it. So I'm pretty excited to see how that expansion works.
Abby, let me know that.
Oh,
go ahead, Abby.
Well, I was just gonna say, I mean, another point that Stuart brought up when we were talking about this yesterday is just the potential for innovation when you bring in technology like this. I mean, you're talking about a generation that is new coming into the market. There's just a lot of potential there, wouldn't you say, Stuart?
I think so. If we look at there's many different game engines out on the marketplace, but the two big ones that are getting a lot of attention right now are Unity and Unreal. And can you hear me all right, Abby? Am I a little closer to the computer? So hopefully the microphone's working better. But anyway, so, both of them are free software. And so there's this global community that's building all kinds of tools and content so that whatever type of game that people actually want to create with the engine, a lot of that infrastructure, a lot of that content is there and the tools are there. So it keeps getting easier and more powerful. And, to Daniel's point about, for large scale visualizations and simulations, I mean, the polygon budget count was always a real problem because, you had to keep it at 60 Hertz and streaming smoothly for the person sitting in the simulator to have that sort of out of the window experience flying a helicopter or whatever. And so we're seeing that the adjunct capabilities like the game engine brings for streaming will have impacts on the geospatial industry. Just the streaming advancements of data are going to make a big difference. And then I would also say I really like Megan's point about the LiDAR point cloud, because not only can you sort of be within the data, but the immersive experience of game engines for the people that are involved with them gives a different relationship to insights in the way that you experience understanding when you're gaming or when you're involved with that sort of immersive experience.
And I think, it makes it not just innovative, but innovation suddenly becomes very accessible. I mean, I think, Dan, maybe you could speak to, you said that you were creating games in your free time when you were like 11 or 12. I mean, that's crazy how accessible this technology is.
Yeah. No, that was game engine. Oh geez, that was just 2D little Mario sprites, but it's stepped up a little bit since then. But yeah, even when I get inspiration today, I work at L3Harris as a web developer, but really just overall programming. And I actually never thought I'd be a web developer when I was younger. I wanted to make games. And so just in my free time these days, yeah, I just re-download Unity or Unreal Engine, whichever one came out with the latest, coolest thing that I saw, and try to use it or use VR. I'm really into my VR setup and being able to just create my own world inside of VR very easily, even if I wasn't a programmer. I kind of, what Stuart said is it's really accessible to a new generation even, and we have people who are just interested in the gaming industry getting trained in these tools. So that's a whole nother industry that people, if we combine the two and the tooling in there, there's a lot more people who could have some great ideas in it.
And it's sort of funny because it directly, while they're learning like how to build these video games and stuff, it actually is also teaching them geospatial things. Mm-hmm. Because when we're seeing people creating maps or creating these worlds, or if you've been playing Animal Crossing and you have an island, you're constantly working with maps and elevation and a lot of the things that will come back into play. So it's almost as if setting up, it just flows so nicely from if you're a gamer or if you like creating these games to actually moving into the geospatial industry where you're working like with remote sensing or LiDAR data sets. I am a gamer, and you're just so used to seeing it in those formats anyway, because you need to use maps. You need to bring in this kind of information that it's almost like it is getting you ready to go into the geospatial industry as well.
I actually just put out a poll. You were talking about being a gamer, so I just put out a poll asking how many gamers were out there.
I'm upset, Abby. I can't vote. It says panelists can't vote, so I'm upset.
You can raise your hand, Daniel.
You don't get to vote. It's funny because I think I'll go ahead and end it, but I mean it's a half and half, so that I think our audience is a little bit of both. I would say, when we had our first conversation, I was taken aback at how lost I was in the conversation, especially because I grew up in the 80s, and I consider myself to be savvy on some level, but I've never had an issue because at least on a marketing level, I understand our business and what we do, but I was just amazed. That's why I had to go out and do the research afterwards. And I'm actually wondering too, I would imagine one of the challenges for using this technology to build out, realistic environments, for use like different industries and stuff, there has to be a line between realistic for the sake of entertainment versus realistic for the sake of being accurate, right? What are the challenges that come with that?
Well, let me start off with this. I'd like to go to the video, Amatria, that we want. So I want to show you a video of a city in Sweden, Gothenburg, that essentially is a smart city, lots of GIS data, and they did a project at Folsom University in Sweden there. And basically what they did is they created a digital twin of the city, and they used Unreal Engine to visualize what would be the impacts of major rainfall events in Gothenburg, and to get the attention. And so this kind of blends, to your point, Abby, a little bit about, and I won't translate the Swedish, but as we're watching this, and this is out on YouTube, just get a sense of the visualization experience that you're seeing here. And essentially what this does is it starts to get the attention of the citizenry about what happens in a city in Sweden that's on the coast with a major rainfall event that could also be combined with coastal surge. Well, that happened in New York City a couple years ago when that kind of thing happened, when you had incredible amounts of water coming into the city. And this is all based on real geospatial data, and you're seeing everything here as visualized through Unreal. And then we're gonna transition here to the GIS data in a minute, and you're gonna see the simulation from a GIS perspective. But this interplay of, okay, this is sort of the emotional appeal for people to get on board with what could happen with a major flooding event in this city. And here is the simulation of the GIS data, which is interspersed with the Unreal Engine's visualization of these events. So I think what this message is here is, number one, digital twins are really important in terms of geospatial, because they allow leadership and to build consensus through simulation. And you can stop the video if you want, Matria. Thank you. So I think this concept of a digital twin is really important, and I think we're going to see more of that. But the digital twin is only valuable if it's based upon real geospatial content. Accuracy matters. So, in the GIS community and the geospatial community, we talk a lot about authoritative data and backing up authoritative data with all of the metrics and metadata and so on and so forth. And that is not going to go away. And in fact, I would predict that as the gaming community really starts to just ingest authoritative data without even questioning it, because the GIS and geospatial community is providing it for them through all the open data initiatives. This concept of digital twins and emotional appeals is going to blend together, so you get all of the accuracy, and you can also get your narrative, kind of integrated with that data. So I'll stop there.
Yeah. Like on top of that, Stuart, you were talking about that authoritative data and using those open data initiatives. Matria, if you wanted to show the Blender GIS,
yeah, that's
either of those animations just quickly, but Blender, for those who don't know, is a 3D software open source that is often used, very powerful. And you'll see here that they're importing data into Blender, which this is where you create those game environments. This is a 3D creation software, and it's often exported into these game engines directly. And so you'll see that there's importing of this geospatial data, geotiffs. Here's a topo, and then the other one. Do you have the other one up?
I do.
Yeah, so this one was using, I believe they import, I think Google Satellite used that. So that's the open data, and then using OpenStreetMaps to do the 3D portion where all the buildings are. So this is that kind of data that you can easily just import with a plugin. This is Blender GIS, and then export into the game engine with that real world data, and get rolling with some of those simulations that Stuart was talking about. So pretty neat.
We do have a couple questions from the audience. How difficult would it be to convert LiDAR data to the Unreal 5 engine?
Well, we're going to watch a video in a little while about some work at Presagis that we did in converting a lot of data into a CDB format, common database format for visualization. But here's the steps that I would recommend is that typically from the LiDAR data itself, if you can bring it in, as point cloud data, LAS files, there is the opportunity to transform that data into Unreal content. I don't know the tools myself, but I think what is really cool is the fact that the Unreal Engine community is global. And if you put that question out there on the Unreal Engine developer site, you are going to get a lot of people responding to you, telling you about, oh yeah, I already wrote a tool for that, I already did this. And that's really what's so amazing about this community is they're so giving. They so much want to get your data into the environment, and the tools are probably out there right now. So I would recommend check out Unreal in the development community, and they'll probably get an answer to you quickly.
And I think the biggest thing missing with LiDAR, because all it is point clouds, right? And so there's points, but there's no what you call meshes over it. So there needs to be an actual surface over those points. Yeah. And so you need to add a mesh with whatever, whether it's real satellite data or some kind of generic one, but you need to create that surface over those points to really create and import into these game engines. So that's kind of a more of a honed in where you need to search is point cloud data and putting a mesh over it. And then you'll be off to the races.
Yeah. And I would add let me just add one more point to that. But, excuse me for interrupting that. So the other big thing that you have to recognize is that whether it's Unreal or whether it's Unity, they look at a flat Earth. They don't look at a round Earth. So that's a major challenge when you've got geographic projections assigned to your data. So one of the innovations that my company worked on with Unreal was introducing how do I get all my WGS84 geographic data, round Earth data into Unreal. And we solved that problem, and we have a viewer called Orb that does that. But typically with games, it's a single scene. It's not large geographic areas. It's a flat Earth, and it's Cartesian coordinates. It's not round Earth and geographic. So I know for a fact that my colleagues and friends, both at Unity and Unreal, are working hard on those problems, and there's contributors. I don't know whether if you have a chance, Google up on the Esri site. There was a talk about the Esri plugins for both Unity and Unreal in February of this year at the developer conference. That's out on the web to take a look at. And so this problem is being solved now. And so if you're using Esri tools, you will have plugins for both Unreal and Unity sometime in the future.
There's actually a comment that came in to us that actually the Unreal release a few days ago has a LiDAR import tool as part of it.
Cool.
They must have known that we were going to be here.
That's what we do here. We solve problems, right?
They want to know the problems of
Game
it.
on, as we said, right?
Right. That's right. And I'm wondering too, to me, the most obvious use of, accurate mapping for game engines and stuff is going to be, like air flight simulators, that kind of thing. Where else are we seeing this? Like, where are we seeing it now pop up in other industries?
I actually have, so related to that LiDAR project I was doing, one of the uses that we used it for, or that a lot of people used it for, was actually for doing scans inside of very important, like a nuclear reactor. So you do an entire LiDAR scan, and you could have one person go in, and I mean, now in the time of spatial distancing, this is even more of a big thing. One person can go in, do an entire scan. You can recreate this entire system, and then using VR and these engines, you can have like the person who needs to go in, walk through and see what is happening inside of that building itself. And so you can actually pull in things like that. That was a pretty fun one, because you could actually walk into the building and move around and see, like, how is it doing? What does everything look like? Because if you put a picture on top of it, that will, you can see both spatially and, spectrally what is going on. And so that's one thing I've run into, is just for management monitoring, for looking at mining sites. It's huge to be able to see the differences that are occurring and like what's moving around and what isn't in like those kind of environments as well.
John, I love Arma. I play it all the time with my friends. It's great. You got some good taste.
We do have another question here from the audience. What are some of the other professional skills you've developed or connections you've made to the professional world through being a gamer? For example, experience in online communication and collaboration, which has been particularly important due to COVID-19.
I'm going to toss that to Daniel or Megan.
I suppose I can start that one, and then I'll chuck it over to Daniel so he can finish it. So I guess as I said, I am a gamer, and the movement from being in an office to being online was a lot easier because I was used to doing a Discord or Zoom or talking to people online and getting things done together. And you're more used to the environment. I love being in the office, and I will be glad to go back when it is safe for everyone involved. But it made the transition easier, and it made it so that when I did have to go to meetings or I had to be prepared for them, it wasn't as much as a change for people who might not have had that sort of growing up as a gamer kind of background, where you are more used to using these tools and getting things done with them. It's just a sort of a change from what the norm used to be. But some people, we already had it a little bit. And so not too much in the professional development, though that does exist. But for me personally, it just made this transfer a lot easier to do. And Dan, you can answer whatever part of that you like.
Well, I'm not in my apartment right now, but it's pretty decked out. So I'm not lacking any internet speed or things like that. So professional help, and tools. I've got a great office and internet speed and computers and expertise in diagnosing my own home office to make sure I can get on. So I'd say that's the biggest impact is I didn't need to bring too much home, or, I've got 5+ monitors that I can access. Yeah.
Awesome. There was a few other industries, Stuart, that you mentioned when you brought up the topic. You mentioned environmental uses, but I don't remember what they were.
Yeah, so, I think that as climate change kind of marches forward, there's a lot of people that are speculating, what does the future look like? And I think that, I want to kind of put this in the context of Tradecraft and geospatial tradecraft. So structured analytical tradecraft typically is a what if type scenarios. What if this happens? So what if a drought persists? What would that landscape look like? Who would be impacted? Where would they go? Or if food security became an issue, or a pandemic, could that ever happen? Became an issue. What happens in urban environments and so forth. So, I think that one of the really interesting areas of collaboration and convergence in tradecraft is the fact that all this authoritative data now becoming three-dimensional and continually enriched with different types of attributes. So, it's not only how tall is the building, but what are the building materials, what are the physical properties of those building materials and things like this, allow you to begin to simulate, if in fact we had 120-degree days in Denver for 3 weeks in a row, which parts of the city would suffer the most, thermally? And as geospatial remote sensing scientists, we understand urban heat sinks and so forth. But coming back to this emotional connection that gaming brings to data, how do you get people aware? How do you get your narrative put together around transformations in, say, climate change, or transformations in, supply chains or food security or whatever it is? And I think that, there has to be an emotional element to storytelling, or people ignore it. So I think game engines play a real role in that.
There's actually a few, kind of speaking to that emotional connection. I mean, I've dabbled in a few, most of them are created by like universities. There's one called like Eco, which is a game engine where, something like Minecraft, you punch trees and, just wipe out the environment. But this one, there would actually be impacts as you mined rocks, you cut down trees, those kind of things. The goal was to, you know, sustain the environment, but there'd be impacts to you, you know, impacting the nature. So that kind of just ran by me. I didn't play it too much, but that was kind of a neat way to get that emotional connection of trying to sustain the world while progressing through the game. So that was a kind of a neat idea.
Related to that one. Oh, go ahead.
No, go ahead, Megan.
I was just going to say, so related to that one, if you've ever played any of the Fallout series, Fallout New Vegas is based from California-ish to Colorado-ish, post-apocalypse nuclear stuff. And I played that before I ever really went into geospatial, but I'd always had an interest in being like part of the USGS or helping with geospatial data. And you actually get to a part in the story where you're in like Colorado and you're moving around. You can go to Red Rocks and you actually are following the diary of a USGS scientist while everything is happening. And, you know, from both a geospatial perspective, you're exploring, but you're also getting this emotional tie-in to his talking about what the environment's like during and after everything that's happened. And it was honestly just, I'm still like, I love that so much right now. I'm like, I need to go back and play Fallout again, but you just get this emotional tie-in because you're invested in what you're seeing.
Right.
And it's so many people are so much more used to it now that in those kind of cases, like that's actually a really good one where it's something horrible has happened and we're showing it to you physically all around you, but you're also getting this emotional tie-in because you're following the footsteps of someone else. And so, you know, when we're trying to build up these visualization examples, that's a really great just sort of way you can bring it all together.
Yeah. The other thing, you know, I'm really excited to show the video of the flight simulator. It's breathtaking and emotional.
Do it.
Yeah, I just kind of, you mentioned flight, Abby, and I just, you know, someone mentioned ARMA and that has flight, and there's also Digital Combat Simulator, but Flight Simulator 2020 is I can't wait for it. Really excited for it because I actually, before I worked at L3Harris, I worked for MapMart, which was acquired by Harris at the time. And we actually, at Flight Simulator by Microsoft 98, we contributed to the aerial imagery that they placed down. But at that time, it was aerial imagery of only certain areas because aerial imagery is not satellite data and takes a lot of time. But it certainly didn't look like this, especially with those yeah, can we go try to full screen that? Certainly didn't look like this, and it'll show all these environments. And I think that, you know, this might blow some people's mind, especially if they're not in the GIS industry, you know, going, wait, that's actually, you know, the place that I visited. Like, how did they get that into this game? Because a lot of the world is simulated, and they'll even have like, yeah, weather systems. They have like animals and birds and such. But it's just something to get, again, people interested in the world that we live in on a grander scale and get them into the industry, and also show some crazy amount of technology simulating the world. They have the real flight tracking. I was telling my girlfriend I'm going to follow her on her trips, get in there and fly alongside her plane in an F-18 or something.
That's not creepy at all. That's not creepy at all, Dan.
That's called stalking.
I'm scared though, if lag happens and she falls out of the sky for a second, I'm going to freak out. But yeah, it's just one of those things that it just gets more interest of like, wow, the world looks really great. And I'm interested in this on more of a level than trying to do navigation from A to B on my phone, you know? So I thought that was pretty neat, and look out for that.
I want to follow up on what Daniel just showed, because that's what we call an out the window view for flight simulators, which is, you know, they're just better and better and better. And if you're ever in Orlando in the first week of December, they have a trade show called ITSEC that'll just blow your mind with all of the hardware, software, simulator environments you can get into. But Patrick, could you go to that one video? I want to just show this other one that it's a video that my company put together that basically solves the round earth problem, but it also brings us down to the street level. And so this is another way to look at simulation. And essentially what you're going to look at is this concept of flying across the Earth with a round Earth projection from Kuwait City to Aden. And you're going to be looking at real geospatial content delivered in what's called common database format and visualized in Unreal. And some of these assets that you're seeing on the ground, like the people that were there, those were created in Unreal, and all the buildings and stuff. And now we're flying, so the Earth is spinning underneath us. And here we are in Aden, and you're seeing sort of these are assets that are put into the video itself. But this is all real geospatial data, and customers that we have that use it for mission rehearsal and planning. Increasingly, the trend is towards what's called reality modeling. So a lot of what you saw there was real GIS data in terms of the heights of buildings and building footprints, but what's called procedural building, where you actually have building wizards which say, okay, this is this type of building, this type of architecture, and you can generate these synthetic scenes really quickly. But the trend we're seeing right now, if you're in this industry, geospatial industry, you heard about, a year ago, Vricon getting the One World Terrain contract for the US Army. And part of the reason they got that contract award was because their collection of realistic 3D models from digital globe data and the way they transformed that photogrammetrically was carried the day, because people want to train in the same world that they operate in. So this convergence between reality and synthetic environments is really narrowing. And the more realistic it can become with sensor data and all kinds of things, that's where we're going. And that's where game engines are going to play a big role.
We do have some other questions here from the audience. Can hyperspectral remote sensing spectral signatures be ingested into the game engine and run through the imagery to look at vegetation, classification, hotspots, etc.?
Megan.
What? Why are you calling me out?
You're the spectral scientist.
I don't believe they have hyperspectral capabilities yet, in the sense of being able to do like hyperspectral spectral analyses for picking out features. For using them as imagery layers, like bringing it in as a color or as an RGB to bring out specific hotspot features, yes, absolutely. But to do like a full hyperspectral analysis, I don't think that's a capability yet. More of so of bringing in like hotspot ideas or those specific bands that work together and overlaying them, or multiple different kinds, or doing a rotation between them to go through these different areas and then use that to bring out the hotspot. So you can use hyperspectral, it just might be limited in the amount of what parts of the hyperspectral you can actually go through in a more scientific way.
Or I'm thinking also using something that is built for hyperspectral, like analyzing that, right? And if you're trying to get a different type of visualization on the results of that analysis, bringing in, okay, here are the areas on the world that have this thing I'm looking for, and bringing that into a 3D visualization engine, game engine, to really get the point across, to look at it in a different angle, but knowing, okay, like here's the farmland that's not doing so great. Let's look at it and in a more 3D format, but importing those areas of interest to really kind of have that data auxiliary and fusion. So that might be another approach.
Yeah, and I would add to that, both great comments, is that the idea of extracting material properties from the hyperspectral analysis and then using those material properties to essentially influence the visualization characteristics of the object in the game engine. So, like Unreal, they use this really impressive ray tracing approach to get shimmer on leaves, to show moisture and all these other things. So I think the concepts of instrumented terrain and using hyperspectral and SAR and other sources to get that instrumentation into the objects is really, really important. And I think we're just at really early stages of how we do that. But I see those remote sensing techniques as critical for material properties, which can be used in visualization. And, when you think about a game engine, it has what's called the physics engine, like in Unreal, it's chaos. And so how do I understand how things collide with each other? What are the material properties when these objects collide with each other, and how they move around in the environment? You have to know those physical properties to make it more realistic.
Yeah, I'm just from a lot of the stuff we've actually been getting as well. The physics engine is probably going to be the most difficult part of moving forward. And I
Yeah.
mean, people are constantly, consistently working on all these different new attributes and things for the physics engines behind everything. But we have all this viewing technology, and that's really where we're going to have to start coming in and giving more information on materials and how things move, on like how things interact with each other. Because if you've played any of the older video games to more modern ones, the physics engines are still a glory to behold in a lot of cases. And that is, you know, if you want these to work properly, you are going to have to go in and make the physics realistic. And
Yeah.
that's probably going to be one of the more time consuming processes in this, but will also be the most rewarding once you have everything done.
Yeah, I think that's a great point. You know, because I, you know, as a gamer, I'm like, you know, some of these recent games, it's like, man, that is so realistic. That is so cool. You know, how this building is being destroyed, and you know, not that I did it, somebody else. But the fact that, you know, I learned it when I came on to L3Harris, there's a difference between, you know, the integrity, or what do we call it? The pixel integrity, or we're from a scientific perspective, there is still lots of room to grow, because while it may look realistic, is it actually truly for scientific purposes? You know, I don't have enough background in that, but it is something from a gamer perspective versus I'm trying to do a research project here. Sorry, phone. Well, are they doing, you know, is that the same thing?
Daniel, you're so popular. You're just such a popular guy. You know, one of the poll questions that I put out there to the audience a little bit ago was, have you ever actually used Unity or Unreal Engine? You know, there's a percentage, about 40% of people that have used it. 34% is like, no, but I will now. I'm kind of wondering, you know, like, what is the learning curve on something like that? Like, if you're a geospatial analyst or you work in GIS, how do you even begin to start playing with that technology?
I can start, if that's all right.
Mm-hmm.
So for me, like I said, I had an interest in it from the very beginning, but I've also been absorbed in GIS my whole life. But yes, the learning curve is steep, I think, to get to that what we're talking about, where it's combining two industries. To start playing around with it, there's so much resources out there. I mean, the gaming industry is huge, and this new kind of fusion of the two technologies is new. So, but like that Blender GIS, like people are using the combination. So I think to start learning the tool in a general format there's tons of resources, but the learning curve is very steep.
Yeah, I'm definitely going to echo Dan's sentiments here. I've created some monsters in Unity when I was first trying to figure out how to do things. It takes a little bit of time to understand both the interface and what you're really trying to draw from it. But there are so many tutorials and resources and just people and forums available out there that even with this steep learning curve, you have people with you the entire way to help you understand and get through it. So it might take some time, but it's not like you're going to be stuck out there alone trying to figure out how all this stuff works.
Yeah, and I'd say larger than the GIS community. So if you're learning on the internet about GIS tools, I find it's way a higher amount of content to find gaming resources on how to use these engines.
Mm-hmm.
So yeah, as a GIS specialist, I think you can get up and going and dragging in items and playing around with it fairly quickly. To get up and running is not a lot, but to get to a point where you probably want to be, it's going to take some practice. But the good news is if you're a business owner or you're looking for this, there's a lot of people with this experience now, and that's kind of the good news. Is that game engine experience is out there because it's so accessible to download and use these. And gaming is so huge now that there's a lot of people, a lot more than when I was a kid, interested in this kind of stuff.
Yeah, I'm actually wondering, so I know you guys have played around with it, Dan and Megan. Have you actually tried bringing in the data we're talking about? Like, have you actually done anything with data that you might have, picked up at work or something like that? You know what I mean? Have you tried to actually fuse that together on your own?
No, I haven't. I mean, I've known about these tools for a while, and I thought that was really cool, but I haven't. But this is getting me pretty pumped about it. So I think, next time, instead of painstakingly creating my own level, why don't I just pull in Denver?
There you go.
And see how that works, and walk around Denver or something like that, using that Blender GIS or something similar.
Yeah, I see Megan nodding her head a lot.
I've mainly, when I was using it, I mainly focused on 3D props rather than landscapes for when I was really using it a lot more. So in a bit of a different way, because you're pulling in different kinds of like imagery to really make sure you have it all correct, but not in like similar to Dan, haven't actually pulled in like a LiDAR or a DM file because I was more focused on the props side of it.
Yeah. And I would also add just that there's more universities now that are basically integrating the two programs together. For example, George Mason University here in Virginia has a very active geographic information systems and earth sciences, but they also have very active gaming part of the academic experience. And, it's not unusual now when you go to a GeoInt symposium or an Esri International User Conference, there's those guys and they're talking about game engine stuff, and they're a university. So I think that more and more, colleges, community colleges are going to be telling about, these types of access to training and tools. And I think for our community in the geospatial community, the really good news, and I think Daniel talked about this and Megan as well, is that you're going to be able to hire people that have been, involved with game engine stuff, maybe since, they were 8, 12, 15 years old. And now geospatial is what's new to them. And they're looking for that crossover point, and they're going to come in with all kinds of ideas and experiences and connected communities to essentially get things going for you. So I think, the sky's the limit really on where this is all going to go with, people's interests and skill sets.
Yeah. I think, Matria, do we have an additional question?
Yeah, so I'm just going to jump in with one last question here. So visualization aside, what aspects of game immersion and interaction aspects do you feel geospatial could take advantage of?
That's a good one.
I'll take the first crack at it, just because I've thought a lot about this, and at the USGIF Tradecraft Innovation, I presented on this topic. So if you really look at structured analytical techniques, and if you think about activity-based intelligence, one of the challenges is, how do you teach that? How do you really rank and look at all sorts of alternatives when you're looking at analytical techniques in terms of, what is my adversary going to do here if I do this or this type of thing? Well, the concept of quote unquote gaming it out, right? You need really accurate data, and you need to be able to bring in different analytics into that sort of environment. But most importantly is you need a group of players that are all from the same community and have a similar type interest in solving this problem. And you start to look at how gamers are interacting on this problem. So if we move away from geospatial intelligence, if we look at issues like urban design, and you start thinking about, how do I get my community to participate in their thinking about a new development environment where I want to blend new building types, new recreational opportunities within a city landscape. Gaming environments where people can come into a collaborative enterprise environment and actually move things around and play, and you get to statistically understand, how do people react to this? I see a lot of big data analytics coming out of this interaction with these 3D environments.
Yeah, Megan or Dan, any thoughts on that question?
Mine is mainly just going back to, besides, being able to physically practice things and being in a similar environment that you might later be in. So like with flight simulators, that technology is also used for flight training, that kind of stuff. So that it already is in sort of that play. But like we said earlier, there also comes into the fact of the emotional aspect. So besides like the gaming engines and the setting up the environment and the interaction with things, you and the younger generations especially are much more emotionally invested in these kind of interactions nowadays. And so if you're trying to get a point across, you have generate like 2.5 generations that have been molded to get and understand emotions from these platforms as well. So like with the Fallout thing that I was saying earlier, and with the video of the town that was flooding, there is more of an emotional connection going on nowadays. So you can also use that aspect if you're trying to tell a story, bring home a point, just in that kind of way as well. So it's not just physically understanding and like moving things around, and that's actually really fantastic too, because you get to do these interactions and test them out, but it's also just building up a connection as well.
Yep, I think they covered it great. Yeah.
We've left him speechless.
It has to be pretty. It's the you know what, it's pretty, and I think it's got to be, we've got to make it pretty, and that summarizes like that emotional connection and that immersion and everything, and really hooks the person in. Because yeah, I may enjoy the GIS, but you know, when you pull up street maps or something and plop on an image and it's, you know, hyperspectral and it's got all these pretty colors, it doesn't tell a story. And we see, like with Esri, they've got the story maps, and now, and so we're moving in that direction where there's this kind of story element to get that connection. But game engines could take it to a whole new level, than kind of a interactive the slides. So.
You know, we're hitting our time limit, and so I'm going to start to wrap up. But before I do that, I wanted to give Stuart a chance. He has an event coming up that he wanted to do a quick plug for. You're on.
Thank you. Appreciate it. So a year ago, I started up an idea around a new working group for the U.S. Geospatial Intelligence Foundation called the Modeling, Simulation, and Gaming Working Group. And so that is starting up, and on May 27th, we have a meeting that we do every month at the end of every month on Wednesday, and we have people from all across the geospatial industry and government to participate. And we happen to have as our guest speaker, Seb Loger from Epic Games, who's going to be talking about Unreal and the Geospatial Initiative. So Abby will probably put the link out on our site, but it's May 27th from 11:30 p.m. to 1 o'clock at Eastern Time, in USGIF under the working groups. You can find the MS&G working group page.
Awesome. You know, as I wrap up this episode, I just want to remind people too that, you know, you can watch the recording for this episode and recordings of previous episodes, as well as register for upcoming episodes at harrisgeospatial.com/geospatial distancing. And in particular, for the next 2 weeks, we have some high power guests that are coming on. We kind of started off with Stuart. He's our first high power, and then we just keep going. We actually have
we had Amanda. She's high powered.
We have some of our friends at Esri that are going to be coming on, including Richard Cook, who's actually going to be discussing, you know, touching on what we were kind of talking about at the end here, which is, you know, how do you prepare for this next generation of analysts coming in, and how do you take on leadership in a remote environment and that kind of thing. So I think it should be pretty interesting. And again, you can register at our page, find out all the info that you need. Until next time, I will just say, I'm going to give you the same sign off I did last week, which is that keep enjoying those sweatpants, my friends. It's going to go away eventually. You're not going to be able to just do meetings in sweatpants. And enjoy it while you got it. Enjoy it while it lasts. So 2 thumbs up for sweatpants. And with that, I will let you guys go. Thank you so much.
Thank you for having me.
I appreciate it very much. Thanks a lot, guys.
Bye.
Thank you.
Bye.
Bye.